First problem you're going to write down, the directions say to identify the measure of the angle below. If you're writing this down, please. I will not take time to write down the directions for each problem. Number 1, identify the measure of the angle below. So what is the quick way for you to do this? Quick way for you to do this, one, is to recognize that you started going downward instead of upward, so your final answer will be negative. You went 1 revolution, which is 360. And then we need to figure out, what is this angle? Well, this is 15. This entire quadrant is 90. So if I take 15 away from 90, I'm left with 75. Please add those up. And then, as a reminder, this is a negative 435 because you go downward first. Next one. So we're starting off with the easier of the problems. Here's your next one. Again, the directions will be to identify the measure of the angle below. First quadrant is 90. And I've used 35 of this. You have to make sure you see where is the measurement. I've used the 35. 90 and 35 is 125. Why is this answer positive and this one is negative? Because I went upward from the starting point instead of downward. Bless you. Okay, your next 2 questions will be to convert from degrees to radians and radians to degrees. So here's your first one. Let's give you 80 degrees, and I ask you to convert into radians. So how do we do that for those that have forgotten? We're going to attach a pi over 180, and then we're going to use the calculator to make this a very simple process. 80 divided by 180, and I hit math fraction, enter, enter. I end up with 4/9, and attach a pi onto the top. When is your next test?
Tomorrow.
Okay, there we go. Okay, here's your next one. This time, let's give you 7 pi over 9. And I'm going to ask you to go backwards to put it into radians. We are going to multiply by 180 over pi. Notice that degrees were opposite in the previous problem, and pi's are opposite in this problem. The pi's cancel. Grab the calculator, take 7 times 180, divided by 9, and this converts into 140 degrees. Is the previous problem wrong if you forget to put a pi? Is this problem wrong if you forget to put a pi? Yes, it is.
Oh, yeah.
Yep. So this may be a new one, but this is not a difficult one. This is maybe new, but it's not difficult. I will read the directions twice. I'd advise you to write the directions down. So this is your 5th problem. For those that just came in late, your next chapter test, the last unit test of the year, is tomorrow. So I'm doing the review right now, okay? Got it? So for those that came in, we've just finished our 4th problem. So if you have to go back and watch the video, you're looking at 1 through 4. Okay, here are the directions for number 5. I would write this down. Use your knowledge of radians and degrees to express the following in order from least to greatest. Use your knowledge of radians and degrees to express the following in order from least to greatest. And although this seems simple, least to greatest means what is the smallest amount up to what is the largest amount. So let me just write down, let me just give you some problems that we're going to put in order here. Do me a favor right now, make this a degrees. I forgot to put a little degrees here with the cosine. Cosine of 1 degree, sine of 1 degree, tangent of 45 degrees, cosine of pi over 6. So our whole goal is just to put these in order from first to fourth. So I'm going to make a little box underneath these. And this is where I'm going to say this is first, this is second, third, fourth. And underneath these, I'm just going to make a decimal amount. So this is in terms of degrees. You learned probably how to do this in geometry, maybe Algebra 1, 2. Please find the button on the calculator that says mode. Okay, we want to start with degrees. Go down to the third row, go across to degrees. So degrees is highlighted, and press enter. Once degrees, you've pressed enter on degree, you can press clear. Okay, now let's go to cosine. Type in 1 because this means the cosine of 1 degree since we have the mode in degrees, and press enter. Okay, I'm going to write this down 3 places after. So 0.99, and actually I'll go 4 places, 98. Okay, we're still in degrees, so I don't need to change anything. Let's hit sine of 1 and press enter. 0.01745. If you're wondering, how many places do I have to write down after the decimal? Just enough places that allows you to put them in the correct order. Okay, we're still in degrees, so let's do tangent of 45, press enter. Exactly 1. Now we're changing into radians. So go back to mode, press enter, go to the third row down, press enter for radians. Then press clear, and I'm going to type in the cosine, don't use 3.14, of pi divided by 5 in parentheses. Press enter, 0.8090. So of all of these, which one is the smallest, the least value? Sine of 1 degree. So I've got that done. Then it goes to cosine of pi over 5. Then to the cosine of 1 degree, and the tangent of 45 degree. On a 1 through 5 scale, can you raise your hand and just let me know how comfortable are you with that last problem? Most of us are 5s, but can you do a favor? We have a couple 4s. Can you check with your partner while I get ready for the next problem? Right here. Can you check with your partner while I get ready for the next problem? Make sure they're understanding. Make sure it turns on. So we are on question number 6. Question number 6. Here's the question. Feel free to write it down. I will say it twice. In which quadrant is the terminal side of negative 105 angled in standard position? In which quadrant is the terminal side of a negative 105 degrees angle in standard position? So you have 4 choices, quadrant 1, 2, 3, or 4. Once again, in which quadrant is the terminal side of a negative 105 degree angle in standard position? So you need to graph negative 105. So here's negative 90. Negative 105 is right about here. So all they're asking is, in which quadrant does it lie? So where does it stop? Quadrant 3. For those that continue to forget your quadrants, I remember it by making a capital C. So I'm first going to just write a numerical value, and then I'll switch to Roman numerals. So I make a capital C. So your C goes like this. There's 1, 2, 3, and 4. What does it look like with Roman numerals? 1, 2, 3, and 4. Okay, here's your next one. Please make a circle. I'll give you a chance to draw the picture that I'm drawing. Please draw this picture to start with. Okay, this portion right here that you see me drawing, this portion is 19 pi over 12. You were told that the radius of this sector is 7 inches. Your goal is to identify the highlighted area, which is this arc length. You want to know the arc length. You're told this length is 7 inches and this length is 7 inches. This is a sector. And this portion is 19 pi over 12. Well, in the past, let's first of all start with, you have to memorize what is the formula for arc length. It is S equals R theta. What does this have to be in terms of? Radians. Okay, so first of all, most students are like, yep, radius is 7, got it. And that's good. What the mistake most students make is in this position, they want to write 19 pi over 12. This is 19 pi over 12. You want to know the central angle. So I'm going to do this two ways. I'm going to do it a slower way and a faster way. The slower way is to realize that an entire circle is 360. So I want to take 360 degrees, and I want to subtract whatever is here. The remaining part will be my central angle. This is the slow way to do it if you think better in terms of degrees. So let's first convert this portion to degrees. So I'm taking, on my calculator, 19 times 180 and divided by 12. I end up with 285. This is 285 degrees. I understand it's not exactly drawn to scale. That's okay. So this is 285 degrees. So if I take an entire revolution, entire circle, which is 360, and I subtract 285 degrees, what would you be left with? 75 degrees. So I know this central angle is 75. But I can't just write 75 here. What do I have to convert it into? So take 75 degrees, convert it into Adrians. How about radians? And you're left with 5 pi over 12. How do you do that again? I'm taking 75 degrees, I'm multiplying it by pi over 180, and then I'm reducing the fraction. All right. On your test, I will hand print in on the district test if it does not say so. If it says round to the nearest hundredth, do that. Round to the nearest thousandths, do that. Or the nearest tenth. Otherwise, we're going to leave this in radians. So how do I do that? I'm going to take 7 times 5 on top, which is 35. And I'm going to divide it by 12 on the, bless you, I'm going to divide it by 12 on the bottom. And then I'm going to reduce the fraction. It does not reduce. So the arc length is 35 pi over 12. I go back and go, okay, this is a distance. It's a distance in terms of inches. Turn to your partner. 30 seconds to go over that problem with your partner, and then I'm going to go over one easier way to come up with this particular angle. And I'll answer any questions after that. Okay, back up here in 5, 4, 3, 2, and 1. Please make sure all cell phones are put away. You don't have any cell phones out. What is a quicker way to do this if you did not want to switch this, convert this into degrees, and then subtract? Notice that 360 is the same as 2 pi. So I could take 2 pi and subtract 19 pi over 12. When you plug it into your calculator, this is an alternative way to come up with this answer, this portion a little bit faster. Forget about the pi. 2 subtract 19 divided by 12. Get an answer. put it back into a fraction, and attach a pi on top, 5 pi over 12. Okay, questions? Go ahead, Jasmine. That's okay? Here's your next one. Okay, your next one is this. State two angles that are positive coterminal angles, with 430 degrees. With your partner, you have 30 seconds. Begin. I'm a visual person, so I start here and I want to graph it. Because it's positive, I go up. Here's 360, and I go, well, how much more do I have to go? So I'm going to take 430 and subtract 360, and I end up with 70. So this is really where I am. So positive coterminal angles. I want to start here and head upwards, and this is where I want to end. So the first one that you could use, because there's an unlimited amount, the first one you could use would be simply 70 degrees. How can you come up with the other ones? You take this, and let's try this. Add an additional 360 to it. So you could use 790. 790 means I'm going like this. Once around, twice around, and back up to this position. So 790 is another one. Or you can add additional 360. It could be 1150. Again, there's an unlimited amount, okay? Yes?
So do the first one.
So I know this is where I want to stop, right?
Yeah.
The only one I can't repeat is I can't say just 730, because that's what the given is. So if I want to end right here, and this is where I start, tell me when to stop. And how many degrees did I just move up? 70, okay?
Yeah.
All right, so let's do one now with two negative coterminal angles. And I'm going to give you a negative 125. What are two other negative coterminal angles? 30 seconds, go ahead. Okay, so the first one I cannot say is negative 125. But I could do a 360 and then negative 125. On a calculator, let's forget about the negatives. Take 360 plus 125, 485, attach a negative in front. That means once around and an additional 125. Add an additional 360, I end up with 845. Attach a negative in front. And you could keep adding 360s to this, okay? How many do you have to state? 2 for the directions, but remember there's an unlimited amount. Thumbs up or thumbs down for this particular type of problem? Okay? All right, you are all going to look over to the sideboard. I'm going to read it 3 times, but you'll see it in the one that says a watch has, okay? You'll work on that problem with your partner once I get done reading it 3 times. so that it's on the video. A watch is running fast and needs to be set back. When resetting the watch, the minute hand on the watch subtends an arc of, can you guys read that to me? 2 pi over 3 radians. Suppose it's radians, I'm sorry, my vision is not so good right now. Suppose the radius of the watch is 2 units. If the watch was at 1:05 p.m. before being reset, what is the new time? That's what you're going to work on with your partner. I'm going to read it 2 more times. Hopefully I can see it better this time. You may quietly start. Just don't start talking with your partner until I get done reading. A watch has been running fast and needs to be set back. When resetting the watch, the minute hand on the watch subtends an arc of 2 pi over 3. Thank you. Radians. Suppose the radius of the watch is 2 units. If the watch was at 1:05 before being reset, what is the new time? Okay, I'm going to read it twice. Please begin. Work with your partner on this, then I will go over it. Bless you. Okay, well, before we can do this, we need to figure out, let's just draw a picture here. We know it's 1:05. There's our minute hand. There's our hour hand. We know that the radius here is 2 units. We know the current time is 1:05 p.m. And we know the subtended arc, that means the inside central angle that needs to be set back is 2 pi over 3. We don't know this measurement that it needs to be set back. So this measurement on the outside is called the arc length. So let's figure out the arc length. It has a radius of 2, has a central angle that needs to be set back of 2 pi over 3. When I multiply across, I get 4 pi over 3. Now I'm going to make a ratio. The ratio will be time over arc length. Arc length that it needs to be set back, okay? So just one revolution around this clock would represent 60 minutes. And we'll have an easier time setting this watch back if we can do it in terms of minutes versus radians. So one time around is 60 minutes. The circumference of this, also known as the arc length of the entire circle, the circumference is 2 pi r. And r in this case is 2. We want to know how many minutes do I set it back if the arc length is exactly 4 pi over 3. So I'm going to cross multiply. 60 times 4 pi over 3 equals 4 pi x. I'm going to divide by 4 pi to isolate the x. Divide by 4 pi. Remember, we're not going to use 3.14. We're going to use the actual pi symbol. I'm going to give you a chance to get caught up, and then we'll plug it into the calculator together. Where did I get this 2 from?
Yeah.
So the radius, sorry, the circumference of a circle is 2 pi r. So 2 pi and r is your radius. Okay, let's do this together. We are going to start by multiplying these together. So let's go 60 times 4 pi. 60 times 4 pi divided by 3 times 4 pi. So I've multiplied this portion. And I'm not going to write down that number because I don't want to round until the very end. Just make sure I wrote this down right. So I'm multiplying, just make sure here. I'm so sorry here. I forgot to divide at the very end. Let me go back here. Let me go back. I've already did the math here. So I'm multiplying these two, and then I'm going to divide by 4 pi. So 1 second, let's try this again. I have 60 times 4 pi divided by 3. That is the top portion, your numerator. Get an answer and now divide it by 4 pi. So how many minutes does it have to be turned back? Put your head up or leave. How many minutes does it have to be turned back? 20 minutes. So if the time before we reset it is 1:05, when you go back 20 minutes, well, 5 of those minutes going back would make it back to 1 p.m., 15 minutes remaining. If I go 15 minutes back, it would be 12:45 p.m. With your partner, 30 seconds. If you can't stay awake, you can leave. Go. What'd you say? How do I get 4 pi over 3? Because this portion right here, this is the ratio we set up. It's minutes divided by the circumference of a circle. And then, or the outside arc, you can think of it as. These are the minutes we're trying to figure out. We need to reset it. And the exact outside arc that it needs to be pushed back is 4 pi over 3. That's this portion we first found, the outside arc. That was our first step. Okay, your next problem. Your next problem, I'm going to read it twice here. Here we go. A circle has a circumference of 8 pi. A circle has a circumference of 8 pi. And an arc length of 19 pi over 9. 19 pi over 9. What is the central angle in terms of degrees? So we're given their circumference and we're told that their circumference is 8 pi. You have to know that circumference is 2 pi r. And we're told that the arc length is 19 pi over 9. We don't know at this point the radius or the central angle. The central angle is ultimately what we're trying to find, and we'll need to convert it back into degrees at the end. So let's solve for r by dividing both sides by 2 pi. Pi's cancel, r is 4. Substitute that into the previous problem. To isolate the central angle, I'm going to divide by 4. So I'm going to take this portion and divide it by 4. Remember, when you divide by a number and you're working with fractions, you ultimately turn division into multiplication, and you take the reciprocal of the second fraction. So this is not wrong. In terms of math-wise, it's not wrong, but the directions say convert it into degrees. So we're going to convert this into degrees by taking 180 degrees over pi. Pi symbols cancel. We end up with 95 degrees. Turning back to your partner to make sure they understand that, please. Back to your partner. Because you're only having a 1 day in this, I will not provide you with an answer to the unit circle, but I'm going to provide you with a blank unit circle. You can start class by filling it out if that's what you choose to do, okay? All right, so we have 6 to 8 problems on the test that are very similar. Here's the first one. The directions for the next 6 to 8 problems will say find the exact value of the function. Exact value. Here's the first one. Secant of 120 degrees. So the first thing I do is I draw, and I'm only going to be concerned with these 3. And then I write the order pair. 1, 2, 3, 1, 2, 3. 2's on the bottom of everything. I know in the numerator anything with the 2 or 3 gets a square root. Okay, so now I have to determine where's 120. So this is something you should have memorized. If not, you still have tonight. This is 30, 45, 60, 90, 120 is right here. The next thing you have to know is this considered a reference angle of 30, 45, or 60? It is. So I'm going to put down exactly what I see for 60, 1/2 and radical 3 over 2. Then I'm going to go back and think about these. Which one should be positive? Which one should be negative? First one is negative, second one is positive. Okay, come back here. Secant, it's not one of the first main 3. So if I were you in the test, this is what I would do. I'd start by writing sine, cosine, tangent. And now I'm going to flip them and go, okay, sine goes, okay, S can't go with S, so it goes with C. C can't go with S, so it goes with S. Just so I can remember what are the reciprocals of each trig function. So I start with the SEC. Whoops, I'm so sorry. This is SEC. I start with an SEC. So I need to get back to the cosine because SEC, secant, is the reciprocal of cosine. So now I come over here and go, what is the cosine at this degrees? It is negative 1/2. But I need to find the secant, so I'm going to flip it. And the answer is negative 2 over 1, or you could just say negative 2. Next one, find the exact value for the cosine of 330 degrees. The exact value for 330 degrees. Okay, so 330, you have to know where that is. That happens to be right here. What is the reference angle for 330? Is it a 30, 45, or 60? It is a 30, so I'm going to take the 30 and I'm going to write it down. Then I'm going to go back and I'm going to put in the appropriate signs. I know it's positive first and negative second. Cosine, remember CBS, cosine before sine. So the answer is positive radical 3 over 2. Do you need to put a plus sign in front? No, if you just put radical 3 over 2, it assumes it's positive. Your third one. Find the cotangent. Find the cotangent of 5 pi over 6. Okay, so cotangent 5 pi over 6. First of all, 5 pi over 6 is right here. Okay, it's this one right here. This is a reference angle of 30. So I'm going to write radical 3 over 2 and 1/2. Then I will go back and I will change it to know that the first one is negative, the second one is positive. You need to have memorized that tangent is sine over cosine, which means the cotangent is cosine over sine. So I want to know what is the cosine of this angle divided by the sine of this angle. Okay, so the cosine is negative radical 3 over 2 divided by the sine, which is positive 1/2. When you divide fractions, you turn it into multiplication and flip the second. The cotangent of 5 pi over 6 is negative radical 3. Your next one. Find the cosecant of negative 3 pi over 4. Find the cosecant of negative 3 pi over 4. Okay, so first of all, let's figure out where is 3 pi over 4. 3 pi over 4, 1 pi over 4, 2 pi over 4, 3 pi. This is positive 3 pi over 4. I just went 90 plus an additional 45 going upwards. But because it's negative, I have to go 90 plus an additional 45 downwards. Here is where negative 3 pi over 4 can be found. Because it's a 45-degree reference angle, I know it's radical 2 over 2. Radical 2 over 2, and they're both negative in quadrant 3. Cosecant is the reciprocal of sine. So let's first identify what is the sine at this point. At this point, CBS, cosine before sine. At this point, the sine is negative radical 2 over 2. So negative radical 2 over 2. But now I need to flip it because I'm looking for the cosecant. So flip it. And mathematically this isn't wrong, but it's not proper. So you couldn't leave your answer like this. We're going to go radical 2 and radical 2. 2 times 2 is 4. The square root of 4 is 2. You will not see this answer if it happened to be multiple choice. You would not see this answer. You would see negative radical 2. Because the 2 on top and the 2 on the bottom cancel. Okay, I'm not going to continue to practice those with you. We're going to do another one. Given, here we go. Given that the cosine of an angle, is negative 7 over 11, and you're told this angle is between pi and 3 pi over 2. Find the other 5 trig functions. So let's come off to the side and let's write those down. So I know I'm going to have to do sine, cosine, tangent, again, cosecant, secant, and cotangent. And I know one angle, and that is that the cosine is negative 7 over 11. Well, the easy thing is, let's go down to, again, C cannot be with C, so the reciprocal is secant. When I flip this, I get a negative 11 over 7. So I have 2 of the 6 already done. Here's pi. Here's 3 pi over 2. Somewhere between these 2 points in the unit circle, you will have this angle. So choose any point in between there, draw a line back to the origin, and straight up till you hit the x-axis, making a 90-degree angle. The central angle will always be the one next to your origin. Cosine, by the way, let's go back and do this. In the quadrant 3, sines are negative, cosines are negative, which makes the reciprocals also negative. Tangent is sine divided by cosine. A negative divided by negative is a positive, and if tangent is positive, its reciprocal is positive. Okay, cosine means adjacent over hypotenuse. So adjacent from this angle is 7, hypotenuse is 11. We don't put a negative 7. That negative is just there because it identifies the quadrant. How do we find the other leg? A squared plus b squared equals c squared. I'm going to subtract 7 squared from 11 squared. 121 subtract 49 is 72. Then I'm going to take the square root, and we should get a plus or minus square root of 72. I haven't broken it down yet, But remember, we're talking about the length of something, and the length will never be described in the negative terms. So right now I know the answer is just positive square root of 72. And I'm going to break that down later to see if there's a perfect square that divides into it. Sine is going to be opposite over hypotenuse. Now let's think about the square root of 72. How can I break it down? So what is the largest perfect square that goes into 72? So you start with 72 and you divide it by our perfect square. It's divided by 4. Oh, that works out. Let's try to look if there's a large number. Divided by 9. Hey, that works out again. I think there's a large number. So we can keep going. Divided by 16 does not work. Divided by 25 does not work. But when we divide it by 36, it does work. So this breaks into the square root of 36 times the square root of 2. Which means the square root of 72 is equivalent to 6 square roots of 2. This is equivalent to 6 square roots of 2. So what is the sign? Opposite 6 square roots of 2 over hypotenuse. Now I need to flip that in this position. So I'm going to do that up here. I'm going to take 11 over 6 square roots of 2. I just flipped it. Don't worry about positive and negatives. It's already taken care of. So I just flipped it. How do I get rid of, how do I eliminate the square root of 2? Times the square root of 2 times the square root of 2. 11 square roots of 2. 2 times 2 is 4. The square root of 4 is 2. 2 times 6 is 12. 11 square roots of 2 over 12. Tangent is sine divided by cosine, but when we're working with triangles, it's even easier to think of the tangent as opposite over adjacent. Opposite, 6 square roots of 2 over adjacent, 7. Okay, down here I'm going to flip this. 7 over 6 square roots of 2. Again, you can't leave a radical on the bottom. 7 square roots of 2. 2 times 2 is 4. The square root of 4 is 2. 2 times 6 is 12. All right, so that one's pretty easy. Let's flip to this one. Okay, we have 2 problems left to cover here. The coordinates of a point on the unit circle. The coordinates of a point on the unit circle are negative 1/2 and negative radical 3 over 2. In standard position, that means once around a unit circle, what does this correspond to? You could give me, because it doesn't say which one, you can give me what is it in terms of radians or degrees. You have 20 seconds, go ahead. So personally, I would look back to your unit circle. Is this a 30, a 45, or 60 degree reference angle? So I know it's here, 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 or here. Because they're both negative, it's down here. Your 2 answers would be 4 pi over 3. What would be another acceptable answer? 240 degrees. If it doesn't say which one you have to give, I'm accepting of either one. Here's your next problem. We have an entire pizza. So draw yourself a very, very simple circle. An entire pizza. One slice of pizza is removed from the entire pizza. You don't know how many pieces exist at this point. What you do know is the slice of pizza that's removed has a radius of 8 inches. And it has a central angle, of 20 degrees. What is the area of this slice of pizza? So what you have to have memorized is area equals 1/2 r² times the central angle. But your central angle always has to be in terms of, so 1/2 times 8 squared. We need to put this into radians. And I get 1 pi over 9. Okay, we're asked for a real life situation here, so we are going to multiply. Here we go. 0.5 times 64 times 1 pi divided by 9. All right, and I would ask that, let's round here. Let's assume they say let's round to the nearest hundredth. So 11.17, and this was inches squared because it's in terms of you're asked for the area. Your very last problem today. Please evaluate the cosine of an angle when you're told that the sine of the angle is 4/5 and you're told this occurs in quadrant 2. You're told it occurs in quadrant 2. You know the sine is 4/5 and you only want to find the cosine. You don't want to find them all. Let's draw a circle. I know I'm working with quadrant 2. There's my central angle. Sine is opposite over hypotenuse. Let's figure out what this one is. Okay, so I have 4 squared plus b squared equals c squared. 16 plus b squared equals 25. B squared equals 9. So you should get a plus and a minus 3, but remember we're only talking about distance, which is always positive. So b is positive 3. Positive 3. So what is the cosine? The cosine of the angle is not adjacent over hypotenuse. If you only say 3/5, you're wrong. The reason is you have to think about in quadrant 2, what are cosines? They are negative.